this video, I'll be going over 2.4 guided notes on solving equations with variables on both sides. So this is our third week of solving equations with variables. So what we're going to be adding on today is that there will be variables on both sides of the equation, and we're also going to revisit the distributive property. So first we're going to take a look at the equation below, and we want to consider how does the process of solving this equation compare to the other equations we've solved? Because like I said, we've been working with solving equations, but we've just been adding layers of complexity each week that we've been solving equations. So we see this image of the balance again, and we saw this in week 1. And this is a great illustration for an equation because we want to keep equations balanced. And that's what the equal sign actually means. It means that it's a point of equilibrium, it's a point of balance. So mathematically, we use the equal sign to show balance. So on this balance, we have 5x plus, and this just represents a 1. We know that this is worth 1. We could call it 1 gram or 1 unit. And on the right-hand side, we have 3x plus 1, 2, 3, 4, 5. And so that's represented mathematically by this equation. So I'll even kind of color coordinate here. The x's are the orange boxes, and then the constants here are the little blue dots on the scale. So the goal is to get all the variables on the same side. We're trying to solve for x. We want to know how much is the x worth. And so what makes this different is that we have x's in two places. We have x's on both sides of the scale. So just as this note says, we want to get those x's on the same side so then we can then get them by themselves. So our strategy here is to move the x's to the same side. So if I'm going to move these x's, obviously the second I take them off this side of the scale, it's going to become unbalanced. In order to represent this mathematically, we're going to use this idea of what I do to one side, I must also do to the other side. So if I take away 3 x's, could just take these away, actually. So if I take away these 3 x's, obviously that's going to make for an unbalanced scale here. But if I take away 3 on this side, and then I also take away 3 on this side, I'll maintain balance because I took away the exact same amount on each side. We can represent that mathematically by using subtraction. So if I subtracted 3 from this side, 3x minus 3x, that gives me 0. I got rid of everything, all the x's on that side. But if I take away 3 on that side, I must also take away 3 x's on this side to keep it balanced. So then these are like terms. 5x's minus 3x's leaves me with 2x's, just as the picture illustrates. Now I still have plus 1, that little blue dot, equals, and I still have 5 over on this side. So now this should look very familiar. This is what we worked on all last week. Now I just have one x, I've got all my x's together, so I can figure out the value of this x by getting the x by itself. So the first thing that I want to do is I want to move this 1 over to the other side. And by move it, really I mean that if I get rid of it, if I get rid of this one, and I get rid of this one, we're staying in equilibrium. So what I did mathematically was if I subtracted the 1 over here, 1 minus 1 is 0, and then I subtract 1 over here, leaves me with 4 equals, and I'm left with the 2x. Now I'm getting closer and closer to figuring out the value of this x. So now all I need to do is use the inverse property of division to get the x by itself. So if I divide by 2, 2 divided by 2 leaves me with 1x, but I must also divide by 2 on this side. 4 divided by 2 gives me 2, so the value of x here must be equal to 2. And what we did over here, by dividing in 2, we're saying, okay, 2 x's is equal to 4 dots. So if I split this into 2 groups, if I split this into 2 groups, then I have 1 and 1. And if I split this into 2 groups, I have 2 and 2. So that is how we get that x equals 2. And we could plug that back into the original and we could verify that that's correct. So here are the steps. Some of these will be familiar, but we're also going to look at this next example, which is going to bring back to our memory the distributive property. So the first step is that we actually do need to distribute if necessary. So as we can also see in this example, I have my variable t, but I have it in two different spots, just like we did on this first one. But one of the t's is kind of stuck in the parentheses. So that's why we're going to distribute, is to get the t out of the parentheses. So that's the first thing we're going to do, distribute. Remember, that means we're passing out. This means I have 3 times this whole chunk, which means I have 3 of these and 3 of these. And when we're distributing, we're actually multiplying. So I'm not doing anything to the left side, so this is all going to drop down. Equals 3 times 2t gives me 6t, and 3 times 2 gives me, this is a plus 2, gives me a positive 6. Now I still have t's in 2 different places, but what we want to do next is combine like terms. That means t's go together, and then these plain numbers go together as well, just like we did on the example above. The first thing I want to do is get my t's together. I could move them either to the left or to the right. It doesn't really matter, but I like to keep my variable positive. So I'm going to move or subtract 2t from this side. 2t minus 2t, think about something that starts with the t. 2 trees minus 2 trees gives me 0 trees. And if I subtract 2t from the left, I have to also subtract 2t from the right. So this 18 just drops down. I didn't do anything with it. And that's equal to 6t minus 2t is 4t plus 6. So now I'm getting closer. I now only have my t's in one spot, but I'm still not finished combining like terms. I've got to get these constants, these plain numbers together. I've got an 18 and a 6. And that is what I want to do to try and get this 4t by itself. So I'm going to subtract 6 over here and over here. 6 minus 6 is 0, leaving me with just 4t, equals 18 minus 6 is 12. And so at this point, we've combined all our like terms. If we're looking back up here, we could color our plain numbers, our constants, in blue, and our variable terms are orange. They're each on their own side. So now we're at the point where we want to solve for the variable. I want to figure out what t is equal to. So in order to do that, I have 4 times t. I'm going to undo 4 times t by dividing by 4 on both sides. 4 divided by 4 gives me 1t equals 12 divided by 4 is 3. So I was able to find that the value of t is 3. Then we can check our answer by substituting the value back into the original. Now, like I've been saying, I'm not going to require you to do this every time, but as you can see, the more complex these get, the harder that is to just do mentally. So I'm going to do a quick check just to show you that this does work. I could plug this back in. So I've got 18 plus 2 times, instead of t, I'm going to put 3, equals 3 times 2 times 3 plus 2. Now I want to use PEMDAS, parentheses first, so I'm going to solve here. So 2 times 3 is 6, and then 6 plus 2 is 8. So I've got 8 times 3 on the right, and then 18 plus 2 times 3 on the left. First, I want to do parentheses, exponents, multiply and divide first. So 2 times 3 is 6. 18 plus 6, which equals 24, equals 3 times 8, which is 24. So yes, this is true. And it means that yes, t really does equal 3. All right, now we're going to take a look at some examples. The first one here is 9x minus 7 equals 3x plus 5. We do have our variable x on both sides. On the left, we have 9x, and on the right, we have 3x. There's nothing to distribute here, so we're going to go ahead and go on to step 2 and combine like terms. I want to get all the variables together on the same side and all the constants on the other side. So what I'm going to do here, I could actually move my x's together either way. I could subtract 9x from both sides, which would give me a negative 6x on the right, or I could subtract 3x from both sides, which would give me a positive 6x on the left. So I want to try and keep things positive if possible, so I'm going to subtract 3x from both sides. What happens when I do that is on the left, I get 9x minus 3x, which is 6x, drop down the minus 7, equals 3x minus 3x is 0, so I'm left with 5. So I was able to successfully get my x's together on the left side. So now I want to move my constants together on the right. I'm going to add 7 to both sides. On the left, I have negative 7 plus 7, which is 0, so I'm left with just 6x, equals 5 plus 7 is 12. Now in order to get my x completely alone, I'm going to divide by 6 on both sides. On the left, 6 divided by 6 gives me 1x, and 12 divided by 6 is 2. So x is equal to 2. In the next example, I have 2 times the quantity n plus 8 equals 6n. My variable n is located on both sides. On the left, it's inside the parentheses, and on the right, I have 6n. So in this case, I do want to go ahead and distribute, because what I have here is 2 of these n plus 8s. So what that means is I have 2 n's, and then I have 2 times 8 as well. So I'm going to go ahead and use the distributive property. 2 times n is 2n. 2 times n is 2n. And then 2 times 8 is a positive 16. And that's equal to 6n. Now that I've distributed, which was step 1, I want to combine any like terms. I want to get the variables together on one side and the constants on the other. So in order to get my n's together, I'm going to move the 2n to the other side by subtracting 2n from both sides. What happens when I subtract 2n is on the left I get 2n minus 2n, which is 0, so I'm left with 16, equals 6n minus 2n is 4n. Now, in order to solve for the value of n, I'm going to divide by 4 on both sides. 16 divided by 4 is 4, and that's equal to 4 divided by 4 is 1, leaving me with n. In this next example, I have 55 minus 10g equals 5 times the quantity negative 4 plus 3g. My variable here is g. On the left, I have negative 10g, and on the right, I have 3g, but it's inside parentheses. So the first thing I'm going to need to do is distribute. What's happening here is I have 5 times negative 4 plus 3g. That means I have 5 times negative 4 and 5 times 3g. The left is going to stay the same for now, 55 minus 10g, and I'm going to distribute on the right. 5 times negative 4 is negative 20, and 5 times 3g is a positive 15g. Now that I've distributed, I have negative 10g on the left and 15g on the right. I want to get my variables together. So what I'm going to do here is I'm going to add 10g to both sides. On the left, negative 10g plus 10g gives me 0, so I'm left just with 55 equals negative 20. And then I have 15g plus 10g, which is a positive 25g. Now I want to get my constants together on the same side, so I'm going to move this negative 20 by adding 20 to both sides. Negative 20 plus 20 is 0, leaving me with 25g on the right, which is equal to 55 plus 20 is 75. To get the g completely by itself, I'm going to divide both sides by 25. 75 divided by 25 is 3, so G equals 3. In this final example, I have 2 times the quantity W minus 1 plus 4 equals 4 times the quantity W plus 1. On both sides, I have the variable W, but in both cases, they're inside parentheses. So I'm going to need to use the distributive property before I can start solving for W. On the left, I have 2 times W minus 1. So I have 2 times W and 2 times negative 1. And the plus 4 is just going to drop down. It's not connected, and I don't need to distribute. On the right, I have 4 times W plus 1. So I have 4 times W plus 4 times 1. When I go ahead and multiply this out, 2 times W is 2W. 2 times negative 1 is negative 2. And I drop down the plus 4. That's equal to 4 times W, which is 4W. And 4 times 1, which is a positive 4. Now I can see that on the left I have 2W, on the right I have 4W. I also see on the left-hand side that I can combine these constants. So I'm going to go ahead and do that first. 2W, and then I can simplify this. Negative 2 plus 4 is a plus 2 equals 4W plus 4. Now I'm going to get these W's together. I'm going to subtract 2W from both sides. On the left, 2W minus 2W is 0, leaving me with a 2, equals 4W minus 2W is 2W plus 4. Now that my W's are together, I want to get the constants together. So what I need to move out of the way is this 4, so I'm going to subtract 4 from both sides. On the left, 2 minus 4 is a negative 2. I'm going to shift this over here. 2 minus 4 is negative 2 equals 2W, and then 4 minus 4 is 0. Last, I'm going to divide by 2 on both sides. Negative 2 divided by 2 is negative 1 equals 2 divided by 2 is 1, leaving me with W. So W is equal to negative 1. We can use the same process to solve more complicated literal equations and formulas. So if I have multiple variables, I can use the same process to solve for a specific variable. So in this first one, I have 3a plus b equals 5 plus 5c. There's an a, b, and a c, but I'm going to be solving specifically for c, meaning I want to get the c all by itself. So we already did some examples like this last week as well. In order to get the c by itself, there are no other c's, so I just want to move everything away. So first thing I'm going to do is subtract this 5 on both sides. 5 minus 5 on this side gives me 0, leaving me with 5c equals, now 3a plus b, and then a minus 5. None of those are like terms, so I'm just going to keep them as is. So I'm going to have 3a plus b minus 5. Finally, to get the c all by itself, I need to divide by 5. 5 divided by 5 is 1, leaving me with c equals, and I need to divide this entire side by 5. So I'm left with 3a plus b minus 5 all over 5. Now, this could be possibly rewritten in some different ways or simplified in different ways, but this is an acceptable answer as is. On this next one, I have 2m minus n equals 7m minus 2, and I'm solving for m. Well, I have m's on both sides. I have 2m on the left and 7m on the right. So the first thing that I need to do is get the m's together. So in order to keep the m's positive, I'm going to subtract 2m from both sides. 2m minus 2m is 0, leaving me with negative n equals 7m minus 2m is 5m minus 2. Now that the m's are together, I want to get everything else on the same side, away from this m. So I'm going to add 2 to both sides. Negative 2 plus 2 is 0, so I'm left with just 5m equals. Negative n and 2 cannot be combined, so I just write them as is. Negative n plus 2. The final step I need to do to get the m by itself is divide by 5. 5 divided by 5 is 1, leaving me with just m. And then I need to divide this entire side by 5. So I'm left with m equals negative n plus 2 all over 5.